In this video, we are going to discuss about the Dalton's law. At the end of this lesson, students should be able to define and perform calculation using Dalton's law. What is Dalton's law? Dalton's law states that the total pressure of a mixture of non-reacting gases at a constant temperature is the sum of the partial pressure exerted by each of the constituent gases in the mixture. Partial pressure is the pressure that a gas will exert if it were present alone in the container. The mathematical expression of Dalton's law is shown below. If gas A, gas B, and gas C are placed in a container, the total pressure of the gases is equals to the partial pressure of gas A, gas B, and gas C. Let's take a look for an example questions. In a container contain a mixture of nitrogen gas and hydrogen gas. The partial pressure for nitrogen gas is 3.0 atm and the partial pressure for hydrogen gas is 2.0 atm at 25 degrees Celsius. Calculate the total pressure of the mixture. Hydrogen gas and nitrogen gas are placed in the same container. Since each of the gases have their own partial pressure respectively, thus we can use the Dalton's law to determine the total pressure of the gas mixture. If a container contains gas A and gas B, according to ideal gas equation, pressure exerted by gas A is equals to NART over V, and the pressure exerted by gas B equals to NBRT over V. According to Dalton's law, the total pressure of a gas in the mixture is equals to the sum of partial pressure of gas A and gas B. By substituting the partial pressure of each gas into the formula, we can rearrange the formula by using the total number of mole and T. By comparing the partial pressure of gas A with total pressure, with assumption that the volume and the temperature are constants, thus it shows the relationship between the pressure and the number of moles. Since the number of mole of gas A in the mixture are represented by XA, thus the partial pressure of gas A is equals to XA times PT, whereas XA is the mole fraction of gas A and PT is the total pressure. We can do the same ways to gas B. By comparing the partial pressure of gas B with total pressure, with assumption that the volume and the temperature are constants, thus we can relate between the pressure and the number of moles. Since the mole fraction of gas B in the mixture is represented by XB, thus the partial pressure of gas B is equals to XB times PT, whereas XB is the mole fraction of gas B and PT is the total pressure. Now, let's try an example of questions. A mixture of gases contains of 0.1 mole of carbon dioxide and 0.3 mole of oxygen. Calculate the partial pressure of the gases if the total pressure is 760 mmHg at a certain temperature. Since the number of mole of each gas are given, we can determine the total number of mole of the gas in the mixture. By substituting the total number of mole and the total pressure into Dalton's law, thus we can determine the partial pressure of each gas. Now, let's try another question. A sample of gas at 5.88 atms contains 1.2 grams of methane, 0.4 grams of hydrogen, and 0.1 gram of helium. Calculate the partial pressure of the methane, hydrogen gas, and helium in the mixture. What is the partial pressure of the methane and hydrogen gas if helium is removed? For question A, since the mass of each gas are given, thus we can determine the number of mole for each gas. To determine the partial pressure of methane, hydrogen gas and helium in the mixture, we can use the Dalton's law. By substituting the mole fraction of each gas and the total pressure into the Dalton's law, thus we can determine the partial pressure of each gas. When helium is removed, there is no changes to the partial pressure of methane and hydrogen gas. According to the Dalton's law, the total pressure of a gas in the mixture is equal to the sum of partial pressure of the gas in the mixture. After helium is removed, there is only methane and hydrogen gas remain in the mixture. Therefore, the total pressure is equal to the sum of partial pressure of methane and hydrogen gas. We also can determine the total number of mole of the gas in the mixture, whereas the number of mole of methane and the hydrogen gas. By using Dalton's law, we can determine the partial pressure of each gas. How to collect a gas by using water displacement method. In laboratory practice, a gas can be collected over water. When the gas is passed through into water, the gas will release and trap into the flask. When the gas release and collide with the water molecules at the surface of a liquid, it will cause the water vapor to escape. Thus, the total pressure is not only from the particular gas but also from the water vapor. Let's try an example questions that using the water displacement method. Consider the reaction. A sample of 5.45 liters of oxygen gas is collected over water at a total pressure of 735.5 torr at 25 degrees Celsius. The vapor pressure of water is 23.8 torr. How many grams of oxygen have been collected? Remember that when using the water displacement method, besides of oxygen gas that has been collected, water vapor also escaped from the liquid. Thus, by using Dalton's law, the total pressure can be calculated by using partial pressure of oxygen gas and the partial pressure of the water vapor. By substituting all the value given, thus we can determine the partial pressure of the oxygen gas. By using ideal gas equation PV equals to nRT, by substituting all the value given, we can determine the number of mole of the oxygen gas. And then convert the moles into mass. This is another example of questions that using Dalton's law. The following figure shows two flasks containing gas A and B, respectively. If gas A and B do not react, what will be the total pressure when the valve is open and the gases are allowed to mix? If gas A has 10 decimeter cubic of volume and 3 atm pressure, while gas B has 5 decimeter cubic of volume and 9 atm pressure. To determine the partial pressure of gas A in the mixture when the valve is open, we can use P1V1 equals to P2V2. By substituting the initial and the final value given, we can determine the new partial pressure of gas A. By using this formula, P1 represents the initial pressure, V1 is the initial volume, P2 is the final pressure, and V2 is the final volume. To determine the partial pressure of gas B in the mixture when the valve is open, we can use the same formula. Substituting the initial and the final value given, we can determine the new partial pressure of gas B. According to the Dalton's law, total pressure of gas in a mixture is equals to partial pressure of gas A plus gas B. Thus, the sum of the partial pressure of both gas is equals to 5 atm.